the technology.
This is what is needed. We brought them all.
Yes, this is the resist temperature and pressure.
1 month.
Yes.
So we should have used the same one. Okay. Every 1 month they replaced the acid.
Many people.
I see.
However, you, for example, you use only one person.
Uh-huh.
You should not prepare everyone.
Maybe in a year.
Yeah,
Just
not,
once in a year.
Or maybe 3 months.
3 months. Okay. We put all into
4,
that. Step 3.
5, and 6. For the
Yes,
camera.
please.
And this is our sample.
Yes.
And then we cover our sample with white cup and press it to cover closely. And then we put like this. Sometimes we separate, sometimes combine. For example, we can use like this. Okay?
Yes.
And then we close.
And we were using that one.
Yes, and then we close this like this. Finally, we close our sample strictly to stand pressure and temperature. How? Like this. We put this across and we close firstly our hands. And then hocam benim dilimde biraz sıkıntı var da.
Dion yapabilir.
Yani can you help me?
This is blank for
Yes,
blank.
this is the blank cap. There is some apparatus to control the temperature in our sample, in our device. Now we add 6 milliliter nitric acid. Only 6 milliliter nitric acid. We can add.
Yes.
We should put our blank like this.
What did you do with this one?
We checked temperature and we checked the hole.
Yes. If the
same-
hole is empty.
Yes. Ben buraya gelmiyorum. Nasıl yapsam? Bunun bir şeyi vardı ama sonra bulamadım. To check our hole.
Sorry, this one, did we put the white?
No,
We don't put-
yes, we don't use a white cup for the blank. Okay.
Okay, I got it.
Yes. Now, please cover it with.
With this one here?
Yes, yes. Because we don't want to change the whole position.
Ah.
Slowly, it's important for us. Container like this.
Mhm.
I will show
Okay,
for
good, good.
you.
This place comes
Yes.
overlaps.
Because we put our temperature controller system in this hole.
I see. I see.
Can you help me to?
Yeah, sure.
You can put first. Leave.
Sorry.
You can. Put
Inside.
inside.
As much as it goes, huh?
Not far. Yes. No.
All the way.
Go inside,
Yes.
okay.
Go inside. During the digestion, it's hold inside.
Mhm.
And then, can I help you? It's important position of the sample. I check our folder.
Everything is in
correct
order,
or
correct?
not correct.
Mhm.
And then close microwave. Open covers. Open ventilation.
Okay.
Before the open, you should use. Yes. Our microwave is on. Now you can see this is the operation part of the microwave. This is the administration. We should like this, and
Bayağı zorlu bir şifre seçmişsiniz.
always
So difficult password.
you should choose the program. Before the experiment, I prepared the program for you, and now we'll look this. This is our program. As you can see, firstly, microwave hold our temperature nearly 100 degree until the 5 minutes, and hold our sample 500 for 10 minutes, and then increase our temperature 150 minutes, and then hold our samples nearly this point. Sorry. We checked our temperature program. This is the ventilation time. You can change the ventilation time in this part. This is the wave changing part. If you want, you can change the temperature or wave voltage or temperature in this part. Finally, you check your temperature program and you can start. But before the start, I want to repeat for you.
Yes, please do it
You
yourself.
check program. Yes.
Program.
You can see, but if you want, you can open another program. Yes, for example, like this. But we used this program for today. Yes. You should press open. You can see the temperature and timing program for this file. If you can change any parameters of this methods, you can change parameter part. This is the ventilation time. You can change this time, and this is the temperature time and volt per parts. If you want, you can change, and this is the final part of your method. Okay.
May I ask a question?
Yeah.
So this is microwave. I think it's 600 watts, like normal kitchen microwave. But it also have temperatures. So maybe when the temperature is reached, it stops maybe. Or do you know how it works? Because it senses the temperature
Yes.
and then it keeps it stable at 100.
No. Controller enable us to what is the
Temperature
real
inside.
temperature inside in our building.
I see.
Sometimes microwave can change the program. What we do 25, 50.
Calibration curve
Yeah.
preparation.
We can see the concentration. First, we read our first standards, and then device intensity. This is the concentration. This is the slope, and this is the blank intensity. Okay, did you understand?
Yes.
I want
think
to
got
check.
it.
Do you want to check this part? Do you want to
This
repeat?
part?
Yes.
Okay. Here we are plotting the intensity concentration curve.
Yes.
So in this we're having different concentration of the
Standard
standards.
Yes. Yes. This standard
Yes,
solution.
the standard solution. So we are having them at different concentrations.
Yes.
So having different concentrations in the curve, the machine, when it's asking for an intensity
Yes.
or requesting an intensity, we are managing to identify the
Yes.
intensity at this much at this concentration.
Yes.
And
For
then at 50
example, it gives us the two. For example,
Two,
two intensity. According to this comparison, generally, device gives us the 5.1. For example, I will give example like this, and we obtain the this curve. According to this curve, we determine the unknown sample. How? We know the intensity. We know the AE value, this value. We know the slope, and we know this. This equation, for example, the calibration curve give us like this. Calibration curve the equation like this, not this. I will give
Just an example.
Just an example,
yes.
that's
okay.
fine.
According to now, and then we read our unknown solution. For example, this is the unknown solution. When we read the unknown solution gives some intensity in this part. According to calibration curve, we determine the concentration of the our sample with calibration curve. For example, we read our şurası y olacak, pardon yanlış söyledim hocam. Y eşittir 0, bula bula diye bir şey verecek bize. When we read our unknown sample, it gives device gives us some intensity for unknowns, zinc and iron.
Zinc and iron.
We have a 100 ppm. What is the ppm? Let's check it again.
Microgram per
Yes,
milliliter.
Yes. You can see the microgram per milliliter, milligram per liter, and this is the ppm. So we have a 100 ppm for zinc and iron. So we want to prepare this standard solution. You can see how we prepare it. Firstly, we dilute our stock solution tenfold, and to obtain 10 ppm.
ppm.
Yes, tenfold.
Okay.
We want to 5 milliliter volume. So we take the 0.5 milliliter and dilute to 5 milliliter. So we obtain the 10 milliliter dilute solution. That's mean 10 ppm.
10 ppm.
Yes, and 10 ppm equal to 10,000 ppb. So because ppm 1000, so this means equals to 10 ppb. So now this is the middle stock for iron and zinc. Now we prepared these solutions. How? Please remember one M1 and one this equation. Did you remember from the general chemistry class?
I really didn't, but I learned from.
Yes, no, not
secondary,
important.
yeah.
I will check. I will repeat.
Sure.
This is what we do concentration of the middle stock, and then we write. We ask what
What's the
volume of the
volume?
use. What is the volume of the use to prepare to this one?
What volume of this we should take to make 10,000?
Yes, it's correct. Yes, it's correct. According to this calculation, we should take 0.125 milliliter. It means 125 microliter. Yes. This, according to this equation, I calculate all of the standards. Like this. Okay. Oh, according to our calculation, we should take this volume tenfold dilute middle stock to prepare this solution. After the preparing, we read our standards to device. According to device intensity, maybe we can extract some standard and we can add standard. We don't know what we do in this
Right now,
experiment,
yeah.
and we read and we see. Okay. We couldn't find
Standard
any place
solutions.
to
Put them
our
right.
sample, but
Yeah.
we are watch. If you want to, if you don't
Turn on
see,
the machine and look at the resistance.
if you don't see this resistance, please don't take it. Okay, and
So
then
it should always be 18.2.
yeah,
18.2.
and then you should write your name and your structure, date and milliliter and resistance in this notebook. 0.5 liter. I checked resistance preparation of the this solution. How like this? Firstly, we take something water, and then
We prepared 1000 DI water. to prepare the standards, dilute the standards, I mean.
And we extract 10 milliliter water in this part.
Okay.
One,
We took 50 milliliter and take out 10.
3, 4, 5. So 1 liter water, and now we add 10 milliliter nitric. So we prepare the nitric acid.
So now we have.
Did you understand? It's a different pathway of the preparation of the solution.
So now here we have 990
Yes.
milliliters of water. We add 10 milliliters of nitric acid.
What? I don't answer.
Here,
Sorry.
here we removed 10
Yes.
milliliters,
Yes.
meaning that we are left with 990.
Not true. It's in chemistry, in physical chemistry, a solution can be mixed in 3, 4, 5, 6.
This is how we label.
You can write the other
Calculation.
standards.
Okay. So,
During
okay,
the-
just sorry.
Yes, during the writing your labeling, I will show the mixing 1% like this. You should mix like this. If you mix your solution like this, if you any accidents, the water can become the floor, not your hands,
Yourself.
not your face, not your any part of your body. It can go on in floor or hands,
Good.
not your
Okay,
foot.
that's fine.
It's important. It's for your hands. Okay.
Okay, that's fine. Okay, only these ones just
No,
PPG
you should write
and for iron
Zan
and,
and yes,
okay.
iron and zinc.
Okay.
Yes. Yes. Very good.
Um,
Because we prepared similar standard, not the same, similar standard for copper and mangan.
okay.
We don't want to confuse.
PPB,
Yes.
50 ppb. Okay.
Yes, very good. Yes. Thank you. Sample. You can use the standards. If you have a too much.
Bundan bir koyduk. Bundan 99 birim.
Sorry, I
Su. 99 su. Bir bu.
You prepare this solution.
We need to prepare these standards maybe every 2 weeks or a month. I mean, depending on the curve we get. If it is not logically, if it doesn't give logical values, this is the first thing we should suspect. We need to prepare these standards maybe every 2 weeks or a month. I mean, depending on the curve we get. If it is not logically, if it doesn't give logical values, this is the first thing we should suspect.
Yes.
So we moved it first,
Yes.
and then we added the middle stop according to these values to each standard.
Now we prepared the standard solution for the iron and zinc. And we again other standard solution for mangan and copper. Why? We have a mangan and copper low ppm values, 20 ppm values. So we need to mangan and copper standard solution. We should dilute not 10-fold. We should dilute our solution 2-fold. So according to our 2-fold middle stock, we should prepare it again this standard solution. But before the standard preparing this standard solution for mangan and copper, we open our digestive system and we press the OK button and
Yes.
then we close our device. And vent, please close the vent. Yes, and open your device. Thank you. And remove your yes. No, not yes. No, like this. No, no problem. No problem. Cover your apparatus and yes, everything. you should remove your temperature control. And then we go to our apparatus to other parts because of the acid fume.
Okay.
Let's go.
All right.
We can put like this part. Kapatmak içindi. In this position, it enables to close all apparatus,
Yes.
but these
To open
positions open
Things,
the
yes.
device. Yeah, can you help me?
Yeah, sure.
I think opens
Nice. Okay.
slowly, slowly. Yes, very good. Yes, very good. Güzel, çok heyecanlıyım. Çözüldü mü acaba?
So
Yes, it's acid fume. Please pay
ah,
attention.
acid fumes
And
come out.
pay attention. Please close it.
So if it doesn't dissolve, one can understand it easily, huh? When you look. I mean,
yes, if
yeah.
you don't see any
Particles.
it means it's a good way.
Okay.
So right now, I think
Yes. We don't want to smell these acids.
Mm.
I think it's a good.
Okay. It looks like without any particles.
Yes.
okay.
Now we close it, not tightly, but close it, and we open other things,
the
and we wait cooling to room temperature.
Okay.
Please open the other parts. I'm going to clear this also hocam. Şarkı.
Well digested. Huh? Okay, we put it to the volumetric flask of 25 milliliters. Olmadı ama 25'i doldurmadık.
Dolduracağım şimdi. Now please look. In these parts,
Ah, of
we
course,
use these
6.
apparatus, and we clean our vessels.
With
Slowly.
distilled water.
Yes, distilled water. The eye water.
The eye
not
water.
distilled water. We use the distilled water, the eye water to each part like this. And then we take this solution in our if you clean your vessel with too much water, it can be access to real
25
volume.
milliliters.
Yes. So pay attention to the cleaning part. Please use the small amount
Volume.
of water.
Mhm.
Yes, small amount of water. And then we clean the vessel, as you can see.
We
There's a
clean
no-
3 times.
There is a no
Hmm.
impurity, or there is a no precipitate, or there is a no sample particles, as
Mhm.
you can see. No. We feel it can be done into our volumetric flask.
To slow down, we need to put tip and then hold it.
You can see. I don't know why, and we will see tomorrow.
And now it goes to
Yes.
a clean falcon.
And closed. Did you try?
Do you want to try?
Do
Yeah,
you want to
sure.
try it? But I want to show one more time and 20 minutes to warm, with warm our device, because plasma stability, plasma should be stable in nearly 30 Kelvin, 30,000 Kelvin. So we should wait to warm plasma to enough
Temperature.
Yes. We should wait nearly 20 or 30 minutes. If you need for this unit type, we can prepare this solution. Okay.
Yes.
You can prepare it because I know it's
1% formic acid. This would be not enough for us. So we prepare again.
You can take distilled water again. Let's remember you should go to the block. Yes, and go to upstream and open the water up. And open device and see the 18.2 ohm water resistance and open the valve and take the water.
Okay.
Did you remember?
Yeah.
Okay. Please cool all water because this water take so many time ago.
Okay.
So
I'll just have to.
yes, you can cool this.
Okay.
And I will do the key for the water.
All right.
You down the upstairs, go to the B block,
Upstairs, right?
and then go to the upstairs.
Okay.
Okay? Alright. B block. Do you remember?
Yeah.
B block.
So I will come.
This is the lab we get the water. We open the lab with special keys we got from Jana. We have to write here, and we have to
Turn it on first.
on yeah
And then.
no don't start it.
Oh.
Okay. Now you can start it. Okay. So we need to see this 18.2. It's the quality control. Yes. And we're right here. So first thing is to turn on the
Yes.
valve of argon.
We use
This one on the left
Yes.
hand side.
this one for today experiment. It's full, totally full. We don't know how our experiments going on. We don't know. So we use this one. This these two, we have nearly 50 bars gas, but we couldn't use for this experiment. If we know how going on our experiment, we can use this. This is not different. This is the same gas,
but it's
all
okay.
of the argon, but there is a so little
Little.
gas.
Ah,
So
y-
during the experiment, if
Might
they finish the
finish.
gas,
okay.
our experiment should repeat again
Yeah,
because
it's 6 inches.
to catch stability of argon. It's so important our experiment. During, for example, we do the experiment. The middle of the experiment, the gas finished. We
have to
couldn't,
repeat
we
the
couldn't
experiment.
catch the stability, so we
So we
should
have to repeat
start
again.
again.
Yes.
Yes. Can you open this gas?
Wow, yeah, that
Yes.
So
Yes.
tap,
Yes.
yeah.
anti-clockwise, right?
Yes. Yes. It's enough. Please come. Chance.
Do we have lights here? Açılıyordu aslında demin. Bekleyince açılacaktı.
Sanki şunu açılıyor.
Doğru.
Yeah,
Nice.
you can see.
Is better now.
Now you can open the black valve.
Okay, blank.
There are two
Yes.
valves, this one
Yes.
and that
Yes.
one.
It's anti-clockwise
No,
until
clockwise.
clockwise. This seems to
But-
be closing. This is closing.
Yeah.
No. It's enough for us. Please open the blue valve.
Blue one.
Yes.
Okay, this one is closed.
All of the close.
Yeah.
Please open a little bit.
Like this.
Okay, it's enough. And open the blue one. Yes, yes. Okay. Can you see the
Yes.
signals of the two
Pressure valve changed.
Oh, yes.
Mhm.
The left, right. Sorry. The right panel show us the argon amount. You can see nearly all of the fuel,
It's almost.
and decrease during the experiment. If you see the zero signals for this valve or
This meter
this meter, yes, it means your argon is
is
finished.
finished.
So the left part, the left meters show us the bar of the argon to go to device.
Mhm.
So it's too high for us. Please close a little bit our.
This one. Level like this.
Okay, but it is not change in this time because all of tubing full with argon.
Okay.
When we open the device, we come here and change it. Okay. To check our bar. Okay. During the experiment, is not exceed 70 psi.
Okay.
Sometimes you can see the water line. You can see. Sometimes we fill water. This line, this tank, this part. Okay. Now we open the part.
We turn it on. This is the chiller. It cools down the water, I guess.
We sit here and
Okay.
and first we open the after open the gas, we open our computer, and sometimes we don't close our computer, so it can be open already. And software signals is this MS signals. You can see like this. Open service windows, and you see the idle. What is the meaning of the? You can start the experiment. Our
It's waiting mode.
Our computer see our device. It means see. And then you open the plasma gas. No, why is no? There is some troubleshooting.
And it doesn't
We had a problem. We just turned on and off many times the computer, and then now we are there.
Yes, our bar inside of the device, it should nearly -7 or -8 millibar. Can you see?
Yes. -7.
Before the experiment, you should check first. Generally, if gauge is off, you should not see. You cannot see this bar.
Yes.
Bar.
10 to the minus 8,
Yes,
right?
yes, the bar amount of the device.
Yes, I remember last time when you couldn't open it was showing gauge off.
Yes, first we opened our software and checked our conditions. If your gauge is close,
Shows gauge
generally like right gauge off. Not you can see the bar of the device.
If you don't see these
Yes.
values, you need to turn on and off. And
Now we open the software. You can see.
and password is I know what I am doing.
Yes, unfortunately.
I know what I am doing without any empty space.
I know what I am doing. All of using with that.
Yeah.
I will give this block notes in this room. You can see if you want.
That's fine.
Now I will check. Sample part comes with these tubings, and this is the peristaltic pump. Do you hear in this pump?
Huh?
Sorry, what?
Can you hear in this pump peristaltic pump?
Peristatic pump.
Yes.
Peristaltic.
Pump enable us to go through the water or go through the sample into this line. Okay. If it works, you can see the pump is going. Now during the
Does it come from the chilling machine?
no,
No.
it's only turning, and we strict our tubing, turning and stricting, and water goes to device. So also simple part of the sample introduction. Now this is the sample introduction part.
Sample introduction.
Introduction. Yes.
Sample.
Sample.
Sample,
Yes.
okay.
Sample come from with this line with these tubings and go to this line and then come into the nebulizer.
Nebulizer.
Nebulizers come from the water to aerosol form
Okay.
and then go to the plasma. Let's remember. And this part.
Water comes from here, right? No.
No, argon comes from.
Argon comes, and here the sample comes,
Yes,
and here is the
This is
nebulizer.
the waste part. Some sample comes from the aerosol and some
Waste.
sample goes to waste. This is the waste line. The waste goes to these easily. First, we take our
Sample line.
our tubing parts in this part to strict type. Yani hocam tam anlatamamış olabilirim.
Ne yapacağız?
Bu döndürecek. Bunları da biz sıkıştırıyoruz buradan. Bunun etkisiyle birlikte sample buradan nebulizer gidecek.
Bunları sıkıştırdık biz şimdi.
Yani bunlar sıkıştırmayı sağlıyor tübingleri.
Tamam.
Bu da döndürmeyi sağlayacak. Dolayısıyla
Sıkışıkken
sample buradan
dönecek mi?
gelecek. Evet, dönecek.
Ha.
Çok sık, o kadar sıkışık
Okay.
değil.
So this thing turns and this thing presses the tubes.
Yes.
Okay. First is just to avoid movement of the tubes, right?
Yes.
Slowly moving, not
Yes.
moving.
Then this thing will still move. And I guess what I understand is there will be liquid here, right? And as this moves,
Yes.
the liquid will be pushed
Yes.
towards
Yes.
that direction.
I get it.
And this is our sample introduction. We take our sample like this. Bunları taktık. Şimdi burada işimiz bitti. Tekrar bakıyorum. Stop. Windows.
Yes, accessories.
Yes, and we click this button and start this button, and we nearly 40 RPM
RPM.
Turning speed.
Turning
speed
speed,
of-
pumping
You
speed.
you can see the
Ah,
speed of the-
yeah, we
yes.
see.
And we click this button, and as you can see,
And how did you put these symbols?
I will explain.
Okay.
I will explain. Now we open the gas. Argon gas, not start plasma, only we open the plasma. You can see the plasma gas is on.
On.
We open the plasma gas and we wait nearly 1 minute to fill all of the
The tubes.
tubing with argon, and then we open the plasma. Plasma is so hot conditions. Have you heard the plasma?
Yeah.
Okay, okay. I will explain.
Plasma is like laser, but it's different.
Yes,
I don't know
so
what's this.
different. Nearly,
Electric shock,
nearly
something.
8,000 Kelvin. 8,000 Kelvin. It's so
Very hot.
and in these conditions, all chemical bonds broke. So, for example, this is our sample. We digest our sample, but in this in our sample there is many proteins, many lipids, many chlorophyll, glucose, many sample
Proteins,
in our
everything.
sample. In this, when we give our device in the sample, all chemical bonds broke in the plasma conditions, and then we say the device, please see only mangan, and device read only mangan ions. Okay. Now we check the bar of our argon.
Evet. Bundan sonra yapalım.
Kaç hocam?
7,5 mu?
8 şu an.
8, 8. What should be the value?
6.5.
6.5.
Yes.
I should close a little bit.
No, you can open
Open.
clockwise part. Close.
Okay. Is it okay?
No. Close little bit.
That close? Or
Not
open?
close. Close. It
No.
should 6 or 6.5.
I'm opening here. So
Okay, can I check? Sometimes I close.
that's opening.
Oh, all the way.
İndi mi birazcık iniyor, evet. Yes. Yes, it's safe. It's enough. Enough. No, it's too much. Tutayım da bu sefer de. Yes. This part is enough. 6.5.
First we have to open it to the end. And
All the way.
Generally, we didn't change too much. We open only gas. But today, we didn't experiment.
Usually we don't play too much.
So we checked this part.
Now we turn on the plasma, right?
Yes. We start the on click. We click on the on button, whatever. Yes. Sometimes these saving things can be changed and we
I mean, what should we do with these parameters?
these parameters are saving parameters, the little these things. But sometimes it can be changed with time or we don't experiment.
Yeah,
So,
when we don't do experiments.
We checked. We
Calibrate.
düzenliyoruz hocam.
This
Söyleyemiyorum.
reorganize? I
Yes,
don't know.
reorganize the saving.
Reset.
Yes, reset. Saving.
But
Points, 7 points.
do you know the values by heart? I mean, ezbere biliyor musunuz neyin ne olacağını?
These are saving points.
Saving.
The small blocks.
Ah.
These are the savings. As you know, you can see the ignition plasma.
So
This is the plasma.
we take all these things close to the saving points,
Yes,
right?
Yes.
Ah.
And sample comes here.
Where is the plasma?
It's here.
Here, plasma.
Yes. Samples comes here and goes to nebulizer and turn it to the aerosol form with the small argon gas and goes to argon and broke all bonds and then goes to mass.
okay.
And have you heard the mass?
No.
detector?
Mass spectrophotometer.
Yes.
Probably she doesn't
That
hear.
is similarly, according to according to mass, you can separate the ions.
Okay,
For
separating the ions.
Yes, for example,
In the
let's
smallest
look,
part.
molybdenum molecular weight nearly 1000, but barium nearly 1037, for example. It can separate according to this mass.
To this one.
Yes. Okay. And
For example, molybdenum will have 3 ions, right?
yes, these are the
Ions.
isotopes of the molybdenum. For
It's
example,
isotopes.
Let's look are elements which are the barium,
Iron.
iron. Let's look zincs. Yes, but you can see the zincs. There is four different
Isotopes.
isotopic ions, but this is the most using ion. Stable plasma condition to obtain stable plasma condition.
After we get operate,
Yes.
then we wait 20 minutes
You can see
for
the,
stable.
You can see the
The sample is
sample introduction. In this part, we checked our device with tune A. You can see the tune A,
okay.
yes. We put the sample introduction part and we checked our ions
okay.
for the device, check the device conditions. Okay. Cobalt, indium,
Tune A.
lithium, nickel, lead, and uranium.
We put it to the sample introduction.
Yes. To check our device. Okay.
Right now or 20 minutes later?
We wait nearly a little bit.
Yeah.
here at first we were just checking the device using 1% nitric acid.
Not because there is no ions in this solution.
Okay, so we're just running the machine.
Yes, for the running and cleaning. Sometimes some students stay dirty our device,
Leave it
and
to-
it can be affect your experiment.
Okay, so that's why we use nitric acid to clean.
But right now we don't use it, right? Right now.
No, we
No,
don't
but
use
we'll do it.
natural.
Okay, first we wash it with nitric acid and then we use the tuning solution and then our sample solution. Then we use tube A. Sorry, we put two things inside,
Yes.
the trash and the
Because
yeah.
we know the tune.
Introduction.
We know tune A is clean.
And we
So
don't want
we
to
don't
waste
know.
it.
We don't want to go to the waste. But
Yeah.
sample for the sample, we don't like. Okay.
yes.
You can see the signals of the tune A for zinc, nickel, and iron that checked our solution, and we should add indium. We should add indium, and our tune A is not contain zinc. We contain nickel, and indium for enough for this experiment. Now we say wait nearly.
So we enable zinc there. We say it doesn't contain zinc, right?
Yes, we
So we
don't.
yeah.
Not important. We couldn't see nearly very good. And copper.
The most important one is indium.
for
We
us.
use that
Yes.
as a standard.
Oh, sorry, Ryan for important. Now we wait to obtain stable plasma condition. How do you understand to catch stable plasma condition? You can see the content. These count of the elements, not amount of the elements. The device determine the elements and give us the signals as a count. Okay. According to counts, we understand the stability. For example, you can see this is nearly stable.
It doesn't change so much.
It can change. You can see. Firstly, 26 and then 30,000. It can be changed. So we should wait to stable to obtain stable conditions. During the waiting time, do you remember? Do you prepare
No.
1%?
We prepare 1%
Yes.
nitric acid.
During the waiting time, you can prepare.
Yes.
Alright, that's fine.
Okay, I plasma gas. But if you see the gauge of the signals, you should close the advanced part and you should open the panning gauge. Yes, panning gauge. You should click the on button. Sometimes it didn't work. It doesn't work. So you should repeat many times.
Okay.
But today we are lucky and
lucky that it
yes,
worked.
we did it. We did it. And you can see the stable signals. It means it's enough for us. I asked the Susan the last that is the last experiment, and the signals is enough for us. She said yes.
Okay.
So now we open the arch experiment conditions. For example, I look at this part and I see the argon problem. So I say that you can open the argon. Yeah, device give us it's too low for us. So we open our argon. Create experiment from the existing experiment.
today's experiment.
Yes. Now we open. Now we open our existing experiments. Now we change the experiment conditions and we say save as for device. Now we didn't change in this device parameter, but analyze. Yes, we changed our analyze. The last experiment, I looked for the selenium, but didn't for the big experiment. We don't look for the selenium. We look for the zinc.
The most abundant form.
Not always
isotope.
most abundant. Sometimes it can be overlap for another ions isotopes. So we checked, we choose the 2 or 3. For example, for zinc, 66, 67, 68, and 70. These are the we choose the 2 of them to check our systems, and now we add the item. Yes, and another ion, another element. Which one?
Manganese
Manganese.
next to the iron.
Yes.
Alright, so
Manganese have a 1 isotope, so we should choose this one. And finally, copper.
Yes.
Am I right?
Yes.
Right?
Yes.
Okay, we choose the copper. Now we write which one? Which one monitoring?
Sorry, what?
Now we write which element, which isotope monitoring. For
Yes.
copper, we monitor the atmosphere.
Now we clean with nitric acid. So this is after A, right? The reference A or tube A.
Yes.
Okay.
Also, 1% nitric acid is a blank for the standard.
Standard
Let's
blank.
remember, we prepared to change the experiment name.
Yes.
Yes,
Q
Dion.
dion.
we can write.
Deon.
D, okay, D.
Deon.
Yes. And dates. Generally, write like this.
We push Q and then this window appeared.
And the
Canan.
window
folder.
Folder.
folder of the journal. Now, we say the example. The experiment starts. Now, the device asks me, did you place the sample? Yes. But the first reading is finished.
Okay.
How we see results and spectrum, numerical results and analyze ICT. I can see the counts of the R elements. You can see iron, mangan, and the device asks me again. Can I start for the second sample list?
Okay.
Device asks me. But if you don't want to start, I didn't click anything.
Okay.
I don't click anything. And I checked our values. You can see our values. We should monitor these values. For iron, we choose copper. This one, zinc, this one, and mangan, this one. And we want to read it for the 1% nitric acid, so we click the continue button.
Okay.
Now you can
It's
see
reading the second
green colors.
Mhm.
Which one of the reading is color is the green.
Okay.
Which one of the finishing?
Color is yellow.
Yes, color is yeah, red. Sorry, yellow.
Okay.
Okay. You can see the conditions of the experiment. 3 sweeps and it's finished. And it can ask washing. And I will check. You can see the central name, 1% nitric acid 1. This is the values of these conditions. After the finishing the second list, you should go tools and calculate results. And you can see the nitric acid. 2 values. Okay. For the iron, this one, you can see the demolished little bit, well, the counts of the iron. And this one is the copper.
But normally this should be 0, right? Because
We
this
don't.
doesn't have anything.
Yes, yes. But we read the tune A, and there is a menu using for the iron and copper for the this device.
Yeah.
So some impurities comes from this. And also sometimes it can be dirty of the this volumetric class, or maybe our 1% nitric acid, stock nitric acid solution can be dirty from
Yes.
the iron, mangan, almost cause the
Impurities.
cause of the blank solution.
Yes.
This is the first standard.
Standards.
Yes. Now first we read our standards.
After acids, we read the standards.
Yes. Now, at the same time, during the taking the sample introduction, I prepared the our standards calibration curve, like this, and and we goes like this. Iron and zinc. Now, in these conditions, we monitor the all iron and zinc because our mixed standards we have mangan and copper, but their value is too high when compared to mangan and zinc. We prepared our standards according to zinc and iron. So we monitored these 2 ions for this reading. Yani hocam biz hepsini mixten hazırladık. Mixte mangan da vardı, kapır da vardı, hepsi vardı.
Diluye
Ama biz
ettik sonra.
kapır ve iron ve çinkoya göre bir standart hazırladığımız için
Evet.
şu an o ikisine bakacağız, diğer ikisine bakmayacağız.
Evet.
Now it's finished. Now we go to like this.
Now the second. No.
Again we read 1% nitric acid to clean to.
Ah. After every sample,
Yes,
generally we clean it.
For example, if your sample air, if your standard is so clean,
Yes.
if you prepare only one standard, not mixing, you can read
Many times, huh?
then our standards. But if we prepare standards with mixed solutions, so we should clean each reading. Then during the cleaning, let's look at our results for iron. This is the iron. Zinc. This is the blank. X means it's 0. We write these counts in these parts. And then we write the blanks in these parts. Now we read the another
less
standard.
diluted standard.
Yes.
So we diluted to standard several times, right?
Yes.
This is distilled water, no, nitric acid. This is diluted.
25,
Yeah. We try to prepare a
You should feel the R
curve.
simple. It's important. What's important name of the leading can be changed after the experiment. And then we read this one. So this value is smaller than 10%.
Yeah, we look at percent RST and we want them to be smaller than 10.
Yes. But sometimes it can be higher than. After you obtain the calibration curve, we check it. If necessary, we reading of these
The ones
solutions
with high
because of the higher
error rate.
percent error. Now we can read sample list.
So we read. Are we reading twice?
No, the first one washing.
Okay.
The second one, read.
Reading.
Okay.
Now is it finished?
So we read the standard 2 times. One is to fill with the standard, then second is to really measure the standard.
Yes. Yes, it's correct.
Okay.
Yani hocam aslında yani biz koyuyoruz biraz bekliyoruz ya
Evet.
hocam. 250 but we didn't reach firstly. If we maybe we can raise like this.
Okay, now we put 100% one. Yes. I can put.
Yes. Tübün içine daldırıyoruz.
Now we wait.
Yes. Sometimes we check with this bottle. Sometimes this bottle is filled, and we change.
Now we wait for some time.
Yes, and in this time we write. Hocam bilgisayarınızı böyle kullanıyorum ama yani size sonradan papya kullanıyorum bu şekilde ama
Tabii.
now we blank subtract, we obtain the blank subtract values. You can see this is our 25 ppb values. This is the blank values. We subtract it.
Okay.
We
So from
subtract
all of them we subtract.
Yes.
the blank.
Pay attention, in this point is important. Not these values, we obtain always the blank values.
I mean,
Okay.
yeah, we subtract always the blank.
Yes. Now, we can make the all at the same time. And let's subtract. Hocam böyle bilgisayarınızı böyle kullanıyorum ama hocam isterseniz sonrasında siz de böyle bir silersiniz.
Yok, eldiven en temizi.
Nereye
Steril.
bilmiyoruz ama. Şöyle. Again, we subtract our values. Yes, is it finished? One 100 ppb is finished, and calculate results, and again changing.
We wash again.
Yes, during the washing. Put
95727.
95727. Yes. Zinc 9449.
9449.
Yes.
Now we go to the insert
Uh-huh.
and then we go to the curve, calibration curve for this one, and we select the data at for the X series. These are our X series. The S series, A series. These are the A series, and then it's finished. For the iron, and we add the trend line. We add the trend line. Display equation on the chart and display our values on the chart. Our
So
values,
you didn't mark this?
our values is important for us. Why? If the R value is 0.999, it means your curve is very good, but it's not for us. And now we read again the 50 ppb value because it's too low according to our curve. Now, now we add the final value.
So 0.97 is not that good, huh?
Yes, it should generally we want to 999, but sometimes it can be acceptable 998. It can be acceptable, but generally if you look like literature, you can see the 0.999.
This value is a bit bad, R value, and then we'll try with 50% again.
198.
Yes.
When we put the 200 one, the curve become better.
Now, could you draw the calibration curve for zinc? Could you try?
For zinc.
Yes. Now go to the insert and go to the curve. Yes. This icon. Yes. Click. Please click icon and this. Yes. And move to another part. Yes. And select the data. Select the data. Yes. Add data. X values. Click X values. You choose 25 and 200. Yes. And A values. Subtract values. No. Not this. Yes. Okay. Oh, very good. Okay. And please, okay. Please go to the curve and click the right side. No, click the right side. Yes, right side. And go to the format data series. Yes. No, sorry, I confused it. Sorry. Right click again. Add trend line. Trend line, yes. And click display equation and display R values. Yes. Close this trend line. Yes. As you can see, the R values
Is quite high.
is good according to iron, but there is some trouble for the 55, 75. So we reread for two of them again. As you can see. Sometimes we add 0 in this part to check the R. Sorry. To check the R for zinc.
Okay.
Now I read 100.
Sorry. So after the
Similar solution but higher concentration.
So
No,
we
I
read
want to
again
check
the
only this
75%.
values, not
and
I obtained correct
the
values.
R
And
value
I can do like
improved
this.
dramatically.
And at the same time, I will wait.
Now
more
she says
times.
maybe we
Okay.
should also try 100%.
I will wait 2 minutes for the food. No, not meat. Please clean it. Clean this block and fry. Mangan and pepper. Yes. Now not click anything and go to the your Falcon to sample introduction. First we mix it. Yes.
We need to mix it first.
Now goes to the put on your Falcon on the beaker. Yes, this beaker and put your tuning in your Falcon. Yes.
Was this nitric acid?
Yes.
Yes.
Now, please go to the results part. Yes, and write mangan and copper. But now, we look mangan 55. 55.
So you're writing this one.
544. This is the blank
Yes,
letter.
5
Now we go to the copper. 65.
566.
Yes, these are blanks.
5, 6, 6. Okay?
Yeah.
Okay, now please start continue.
Continue. Now we are running the 25.
Now, but you can see the watch the time.
Okay.
Now, device watch,
The first one is a wash.
yes,
The second one is a read.
reading, and the third one is another reading.
Another read.
Yes. Now you can write to continue. You can click continue button.
We just say continue, nothing else.
Now you can go to the, without clicking anything, go to the toolbars. Yes, no, calculate results. Go to the result part and, yes, this is the results part. No, please go to the down. Little bit down. Yes. And write mangan for this mangan is value.
17171.
171 again.
Yes.
Yes.
17171.
171.
Yes. And
For copper, 65.
Copper 65 is 3144.
3144.
Yes.
Now, please put your new standards.
Okay.
Now we don't need to wash with acid in between. We can just go to the more diluted.
Yes.
We did
Not now.
with the nitric acid.
We did it.
Yes.
But
Just
we don't
for
have to.
minutes.
Huh?
But sometimes for the second and third reading,
Yes.
we don't know. Because we know the values, for example, 6.
Yes.
Maybe 6.2, maybe 6.1. Can
Okay.
be changed, but we know the 6. But the first time, we should clean it.
Yes.
Now,
Okay.
please go to the sample list. Yes. Change your sample name.
Second one is now
50 ppb. Coverage. Coverage. And please change your tubing. Yes. When you do the experiment alone, in this time you can write the count your computer.
Okay. So
In this time, your waiting time.
While
Go
waiting
to
for
sample in your sample
cleaning.
in your device. And then start to continue clean. Please don't forget to fill into this part. Sometimes I forget already.
So right now I can write, right? Why this one is there?
Yes.
So
We changed name
With
of
this,
sample.
okay.
Changing the our platform.
okay, yes.
Now you can again continue to reading real sample.
We did the dilution curves. 0.998 is very good, right? 998.
Yeah.
Yes, but here it's not that good, but still it's okay. Then we filtrated each sample with a different syringe. And now we'll read our samples. When we measure our control, the iron was more than 200, so we just diluted twofold and we'll try again to fit in this range. Okay, every time the same. We put this thing from this to the sample. We push and we make sample list, and then we push continue 2 times. Anyway, I'll show you. Okay, we go to sample list. We make new columns. Oops. Shit, something happened.
Let's check the next one, the unknown part.
No, we are not in the unknown part now. Yeah, I'm somewhere. Okay, here we write the name of the sample. Okay, maybe Dion you should do it. Yeah, I mean after doing that. So Dion is now diluting. While diluting, the tube is in acid 1% HNO3. And after dilution, we'll put it here. We put it there, and we wait maybe 2 minutes. And then we go back there. And what are we gonna do? We are gonna push continue. Then the machine makes one washing. Then we again push continue. And after the sample turned to yellow, we come to the tools, say calculate results, and then we come to the results and take these values and put them in our Excel sheet. Hemen bir şey yapayım mı unutmadan? We after we finish all the samples, we use nitric acid, and then we do DI water. And how long? Maybe 2 minutes. Yes. Okay. Yes, we're shutting off the machine now.
After finishing all reading,
After reading and cleaning.
we click
Cleaning.
the off buttons.
Off.
Yeah, sorry. First we abort our experiment.
How did we abort?
Actually,
Abort.
generally we close our device like this. Click off button 2 times. But for today, device give us if
Error.
you click the off buttons, vacuum gone. So I want to stay vacuum inside our device. So yes, that works. So I used this method. Generally, we close our device off button clicking 2 times. But today, when we click the first one, device give me
Error.
click another time, vacuum gone. So I don't want to go vacuum gone. I don't want to I don't want that vacuum is gone. Yes, there is no problem. Yeah, I can see it. Okay.
So what is it doing right now?
I wait to closing device.
It's like closing ceremony.
Yeah.
Interesting.
Actually, generally we click in the off button. Device can be off, but today there is some problems in our device
Yeah.
software.
I still see some peaks.
Yes, yes. As you can see, if you click, now device wants to correct this answer. Do you wish the switching sound vacuum state? Yes. Now device go to the vacuum state. First we close the slide bar in the device, and then let me wait. Again we click the second time. Oh, sorry. Switching, cooling, and then vacuum ready. After you see the vacuum ready, he goes to closing circulator and gas. Yes. During the waiting time, we open the tubing folder. As you can see.
Yes, I can see it.
Closing, still opening. While we open, you stay. If your tubing is too long time, the
Stress.
can be start.
Yes.
As you can see, vacuum ready, but I don't want to pour all of water in the sample introduction. So, as you can see, this is the vacuum ready. I go to instrument and again I open the sample introduction because I don't want to stay water in our sample systems. Okay. I monitored a little bit. Sorry, şunları da kapatmam lazım. Sıkıştırsın. Bunu neden yapıyorum? Normalde bunu yapmıyordum ama suyun içinde kaldığı için cihazı kapattım ama sample introduction'da su kaldı. Ben sample introduction'da su kalsın istemediğim için cihazı kapatmama rağmen, vacuum ready yazmasına rağmen instrümente gelip buradan accessories gelip buraya perisaltik pompayı açtım tekrar.
Su buradan gitsin.
Aynen, buradan da su çekmek.
Yes, she wants to get rid of the water.
Water inside.
Evet,
Inside, yes.
görüyorsunuz, gidiyor.
Görüyoruz.
Now the device is closed. Vacuum already staying stable, nearly -7,
Now we turn off this machine. Yes. And the valves.
Only close
The blue one.
blue and this one. Yes. Please
That one
close
and the blue one.
Yes.
Blue.
Close.
Blue.
and
Blue one.
yes.
Blue one.
We didn't move this
Blue,
one.
blue one.
Generally, for example, you come next week. You will come next week, and you will data.
How do we get the raw data? Export CSV file.
I labeled our CDS file like this.
Yes.
I say this as the same. But I put now I go to the internet. Burası NES kısmı. Burada
Ne kısmı?
NES kısmı.
Evet.
Kütle kısmı. İyonlar burada ayrılıyor.
He.
Dolayısıyla
Bunlar açık kalıyor.
bu vakum hep
Vakum açık kalıyor. Böyle kapattık, bilgisayarı kapatıyoruz, topluyoruz.